So we're finding the vertical asymptotes, the holes, and then the domain of the following rational functions. So function 1 here, g of x equals this. Let's go ahead and graph it and see where the vertical asymptotes are at. Should we, or should we do the work first? Let's go ahead and find the vertical asymptotes, the holes, and the domain. Let's do that first, and then we graph it. Okay, so as a rule, whenever you're working with rational functions, is to factor it completely. So main suggestion, factor completely. All right, let's do that. X plus 2 is what? It's a set. If you're gonna go with me, it's a set. It's indestructible. It's one unit. It's one thing. It's one thing. X plus 2 is one thing. It's a set. Are we gonna do the x here, or can we just like quickly do it like grown-ups? Can we? Yes, let's go. Like we can just do it like this, no? For sure, it's gonna be what? X and x. Man, why? Maybe I should like stop doing these x methods and whatever. Can we just like do it quickly? Oh, I got it backwards. 2 and 4, 4 and 2. Okay. Yes, that works out. What can we do after we factor completely? What do you think we can do here? We can cancel off the x plus 2 with the x plus 2, and we're going to get g of x equals what? Who already wrote a 1 over x plus 4. Yes, yes, yes. 1 over x plus 4. But let's not forget, I'm going to do a semicolon. I think that's what this thing is called. X cannot equal, let's not forget that x cannot equal to what? For this that I cancel off. Because you can't have a 0 at the bottom. And if I substitute in for this x, some number, it's going to create some 0 at the bottom. So x cannot equal to what? X cannot equal to negative 2. Because if I plug in for this x negative 2, then I'm going to get negative 2 plus 2 is 0. And 0 times anything is 0. And I cannot divide by 0 because we can't. Okay, so then this became this function here. Now we can get all this information of vertical holes and domain from this right here. So this right here is gonna, this is a hole was created here. There's a hole here. Whenever you can cancel off a factor at the top and a factor at the bottom, it creates a hole in the function. Otherwise, it is a vertical asymptote. So it has a vertical asymptote at where? At x equal what? At x equal what? Negative 4. And again, why is that? What is if I plug in for x, negative 4, what is negative 4 plus 4? 0, yes? And you're gonna get some 1 over 0, which is undefined, we don't know. So it's a vertical asymptote at x equal negative 4, and there's one hole at where? X equal to what? Holes at x equal to what? Negative 2. And so the domain will be what? What's going to be the domain? All reals. X cannot equal to the hole or the vertical asymptote. At x cannot equal to what? negative 2, and also x cannot equal 2. X is not defined there at negative 2 and negative 4, because at negative 2 it has a vertical asymptote, and at negative 4 at negative 2 it has a hole, and at negative 4 it has a vertical asymptote. Yeah, let me go ahead and put this in a graphing calculator so you see what we're talking about here. All right, let's go. So one person, remember to tell me what this function is, and I'll put it in a calculator. Where'd it go? Here. Say no. All right, here. Y equals f of x. Y is f of x equals, or a g of x it was. Y equals, let's do a fraction. How do I get it? How do I do fraction here? I do a fraction, is that something? Yes. Y equals, I said it was x plus 2. X plus 2 over some x squared, was it? Yes. X squared, was it plus? Is it 6x? Plus 8? Plus 8? Wow, so look at this technology. At negative 4, that's where, where's my, can I annotate now again? I can, yes. So there's the vertical asymptote right here. At negative 4, because it's just going to go to negative infinity and positive infinity. And then it's supposed to have a hole where? What did I say it was a hole at? Negative 2, we said? Sometimes technology is not perfect. This is not perfect. It's showing that it's defined there, but really shouldn't be defined at negative 2. No, let me get rid of, it's okay. So it shouldn't be defined here. What? Oh, what does it say? What does it say? Oh, what does it say? You see? You see? You see? Yes? So if this was actually decimals, you're cool and everything, but you're still not perfect because you should have a hole here. Anyways. Moving on, back to problem. Leave. All right. Present. Enter full screen. All right. Let's go. So as a rule of thumb, factor it completely. And then you can get all these vertical asymptotes, holes in domain of the function. So there's nothing really to do at the top. What are you going to do with 1? Nothing. But we can go ahead and factor the bottom. And we hope that it is factorable. Definitely x and x. What are the numbers here? Are you saying negative 4 and negative 3? Is it? X squared, negative 3x plus negative 4x, negative 7x. Negative times a negative is positive 12. Yep, that's perfect. Yes, that's like actually math. See, the other stuff is childish. This is actually math. The way maybe that's why those people over there were like, don't do that. Teach it like this. That's math. Vertical asymptotes. So, did anything cancel out? Like, how we did here? Look at this, cancel out. That creates a hole. So then this will have definitely no hole here. Let me already say there's none. There's no holes. But there are. How many vertical? That's why we put the little S here. There might be more than one vertical asymptote, and there are two of them here. So vertical asymptotes add what? X equal to what? Positive 4, and add x equal to positive 3. And so the domain will be all reals. X cannot equal to what? 4 and 3, no? Where the asymptotes are at. Can I just go like that? 4, comma 3, without writing too much. You believe me, no? You don't want me to go to the decimals and graph it, and or you want me to? No? You believe it should be good? Let's go. Let's move on then. So let's speed this up. We got one more problem to do, and that's it. We're done for today. Easy. Okay, problem number 3. We're done after this. Problem number 3. Here we go. Problem number 3. Again, what's the moral of the story here? The moral of the story is that if you don't know how to factor, then yeah, you can't even get started in trying to figure out what is the vertical asymptote of O and domain. I will retract and say that for these kinds, I do like the X method. Let me give you 4 minutes to factor it, and do it your way, whatever way you want to do it, because it goes back to the story about I need to get to work and I'm at home. I can drive to work, I can walk to work, I can Uber to work, where the whole point is to just get to work. So the whole point here is to factor. There are many ways to factor. I specifically showed you, and I stick to the X method, but sometimes the X method is too much. But for this one, you definitely would want to do the X method. That's my suggestion. But if you're really good at math, you can just like think it through, like we did just barely. Ready for more credit, Brian? No? But we're not solving, Brian. We're just trying to find the factors. If we were solving like equations, then you would want to do quadratic formula. But not this. We're trying to factor. But that's nice. That's good thinking outside the box, though. What, you found it there? where you like lose. Yeah, I go with that one. You don't like doing X? I talked the last class about my method, but my method is on. You just don't do it for simple, easy ones. You don't need to be doing it for like that one. Those are so easy. Like, it's so mindlessly simple to do the X method up here. I'm just gonna go ahead and do it, and just you be your own judge and say if you're trying to be like, I'm gonna do my own method. You better be good at your own method, whatever method you found on YouTube or your teacher teach you. Anyways, here, let me do this first one, top one. Middle number to the bottom. First times the last. 2 times 24 is 48. Two numbers the most. 16, negative 16, and negative 3. Yes. Divided by 2, divided by... So simple. It works. So it's going to be on top. I already know it's going to be what? Is that negative 8? Yeah, that's negative 8. So easy. Bottom to the front. Bottom 2x minus 3. Let's see what number is that. 6 and negative 6, negative 5. Yeah. Negative 5, negative 6. Yes, people, yes. And then what? Because it's just the method, just that's the way you better work it out. You better divide by whatever that is. It's just a method, and it works. So this on the bottom is going to be what, 2x minus 5? Yep, 2x minus 5. And that's negative 3, negative 3, x minus 3, yep. Nothing will cancel here. Nothing cancels. So where will be the vertical asymptotes at? So it has no holes, none. The vertical asymptotes will be at what? You actually have to solve. Maybe. So where is it at? At x equal what? Positive 5 halves. These are from the bottom. These came from the bottom. Yep. That student 7 years ago, which I might be lying, he's like, hey, you can get the x-intercepts at 5 halves, positive 5 halves. And then the other one at negative 3 is going to now become positive 3. Yes? Oh, no. You need me to solve them? No? And then what? What's the domain? All reals. X cannot equal to what?